Hello, everybody. I want to welcome you to another session during the Universe 2 Hackathon. Today or now, I will talk about how to make an NFT using the AEX 141 standard on the Æternity blockchain. So what can you expect from this presentation? I want to just give you a short overview about that. So we're brand new in that area, or let's say we're just getting started with NFTs on Æternity. So this means that we basically, over the past weeks and months, standardized the AEX 141 standard, and it's still kind of liquid, the standard, so there might be small issues. It's still under review. It's not heavily used right now. But yeah, so this means there is no UI launchpad, no minting UI, launchpad, or any marketplace available yet. But yeah, this is why Hæckathon exists, right? So if you are interested in the NFT space, there is plenty of room to develop new and cool stuff here. I created an example how to do that programmatically. So you can find the example on our GitHub. The link is provided here. I can also provide it to you in the chat or later, and on all the sources on DevPost and Discord, on GitHub, you will find it. Just ask us. And yeah, another thing is the step-by-step guide, how to programmatically create an NFT collection, mint several NFTs, and use the CLI to fetch some NFT metadata directly from the contract. Yeah, short overview about the agenda of this presentation. I want to shortly just explain why NFT standards exist and why they are needed. I want to make a short comparison between the well-known ERC 721 standard and our brand new AEX 141 standard. And I want to tell you how to deal with metadata and what our first proposal here is. Yeah, and then finally show you our sample collection, which is called Apes Stepping into the Metaverse. Yeah, we will deploy a contract, or I will show you how to do that based on a screenshot story. Yeah, we will mint the NFTs and we will fetch the metadata, and I will show you how this is done in the example. Yeah, and what to build, I want to give you some ideas what you could do if you're interested in NFTs, and of course, last but not least, tell you about our social channels. Get in touch with us. We're happy to help you with everything. Yeah, NFT or standards in general, why are they needed? So we have to define some rules around how we treat or how we deal with smart contracts, or the code in general. Yeah, and the strict rules are for everybody to follow, and they are defined in a standard definition typically. So for example, the most known and distributed standards in the blockchain world are those for the fungible tokens and those for the non-fungible tokens. They are widely known, and everybody knows about the ERC20 standard, which is mainly used on EVM-based chains. We have our own virtual machine and our own programming language, so we had to came up with a new standard here, which is the AEX9 standard. There, in another talk, Keno talked about our automated market maker, the superhero DEX, where you can trade those fungible tokens. But yeah, it's kind of the same, but we had to introduce a new standard on the Æternity blockchain. The same goes for the non-fungible tokens. Here we have on EVM-based chains the ERC 721 or the ERC 1155. And we now came up with a proposal together with Ayan from the community. Here, heavy thanks to you. Was a good collaboration. And yeah, now we finally have the AEX 141 standard here on Æternity, which is more aligned to the 721, ERC 721. And this is also the reason why I compared these two together over the next slides. And yeah, standards in general can also be extended by more complex standards that build upon the lower standards. So yeah, you have always the baseline that can be extended. And why is it needed? It's mainly needed by marketplaces or platforms in general, that everybody knows how to treat the code and how to interpret the code. Otherwise, we would have we would be in a jungle. Everybody would do their own stuff, and it's good to align on a standard and know how to implement it and how to interpret it. And the same goes for the developers. It's very useful for the developers because if they follow that standard in their implementation, they can be sure that the platforms all support their code and their implementation. So yeah, we need a standard, and as already said, it's still in a kind of liquid mode. It's in review. So if you see any problems with the standard in general, please get in touch with us. Let us know. We will then apply and update it accordingly if it makes sense, right? So that's open for discussion all the time. Maybe we have to introduce several other standards, or also on the standard we have some extensions, so you can extend the standard and define new entry points there. But yeah, that's open for discussion. The key message is it's very important to have NFT or general standards that everybody follows. Yeah, a short overview about the difference between the ERC 721 and the AEX 141. On the left side, I just took a screenshot of the Open Zeppelin documentation, but you see there are several functions in the core ERC 721 interface, like get the balance, the amount of how many tokens a collector owns. Then we can fetch the owner of a specific NFT with a token ID. Then we have two different methods here, a safe transfer method and a transfer from method. So here is the first difference, because we don't allow on our side to have unsafe transfers. What does that mean? It's like you could, for example, send an NFT to a smart contract, and if the smart contract isn't able to deal with that token, it's basically lost and locked forever in that contract. And we don't want to allow that and immediately forbid that. So there's only one transfer method on our side, on the AEX 141 side, which doesn't allow unsafe transfers to contracts. So every contract has to implement the AEX 141 NFT receiver interface. Yeah, and there are several other methods. So in general, we really aligned with the ERC 721, but we are more flexible. For example, if you see on the right side, we have the metadata type and the actual metadata. So you can choose currently from 4 different metadata types. The commonly known URL, where you can just have a base URL on contract level, and then the ID of the token afterwards that can be used. But yeah, we want to just provide flexibility here. What's also necessary for metadata in general is not only on contract level, we need to align on how we structure the metadata. So this needs to be written down somewhere. It's not 100% defined yet, but we have one proposal in this talk and in the example. So this will be the first proposal we can use here. So yeah, next to URL we have IPFS, so you can directly point to some IPFS hash where all the metadata for all your NFTs could be included. So but also here you need to define how to treat that IPFS hash. What stands behind it? I mean, it could be a JSON file, it could be an image, it could be everything that's stored. It could even be a folder on IPFS. So yeah, here we are very flexible, but you have to define how to deal with the data. That's not yet done. Then we could have an object ID where every NFT has just a unique identifier, like the vehicle number, which is unique, or something else, mainly related to physical objects, where you have the a specific unique identifier of some existing physical object. So this could be used there. And last but not least, we have the map metadata type. This one is also the one we use now in our proposal. So we can provide a key value map with string, but the string value here could also be a JSON string. So you can also provide other objects or more complex data structures. It's possible if you just provide a JSON string there in the value. So we are also quite flexible on that front. And for the metadata itself, you see we have two different variants here. We have one is the metadata identifier, which has to be used for URL, IPFS, and object ID. And then we have the metadata map, which is basically only used for the metadata type map. And Sophia in general is a strongly typed language, so it's very powerful. We can ensure to not let you make mistakes that you should not do, for example. You can create the data types like you want, just to ensure that developers don't make too much mistakes. Yeah, and then we have the supports interface on the left side, the ERC 165 definition. We replaced that with our AEX 141 extensions list. So you receive a list and see all the extensions of that standard that are used. Independent of that, we're quite followed the ERC 721 standard. So there is much similarities, but I think I highlighted the most important stuff. So in my opinion, we are safer, we are more flexible, and yeah, of course, Sophia is the better smart contract language. So you better stick to the right standard. Okay, what's next? Dealing with metadata. It's one of the most important stuff. I mean, I already said that you have many possibilities. In this example, before I go into the example, first, a general advice that you should avoid using URLs that point to traditional websites. I mean, that's not the point of decentralization in that sense, because data can get lost. So if the domain owner loses access or the domain expires or is transferred to another owner, you can just replace the URL to point to something different, right? So data can get lost and it can be manipulated. If there is no proper check provided by you as an NFT collection creator to provide your users a way to verify the metadata against that. But anyway, my personal advice is just to avoid that. So it's better to store your external metadata on a distributed storage, like for example, IPFS or Arweave. There are multiple different options here. But whenever possible, use a distributed storage, please. But here you also have to know somebody has to pin the data. So if you upload it on some distributed storage, not everybody has an incentive to save and store your file there. So you have to either do it by yourself or pay some other service to do it, or you just have an active community which is encouraged to pin the data on their own distributed storage. But the good thing here is if you have access to the original file, you can easily recover it and pin it again, because it will always generate the same hash. So that never changes, and that's quite a good thing here. Now on the bottom, you see our example or first proposal now that we think makes sense for NFT metadata of collections in the AEX 141 standard. So we will probably propose a new extension for that, just because we have on the very bottom, we have the mutable attributes. And what we want to provide here is that if you have some game item which can level up or something like that, you should be able as owner of that collection to upgrade the NFTs in some way. but of course you always have immutable attributes. So we have to provide a standard how to deal with that and how to treat mutable attributes. And typically or usually it will probably only be allowed for the owner of the collection or the contract to change this mutable attributes. Yeah, but we haven't demonstrated it yet, but it will be added to this example at a later point, just to let you know. But yeah, what do we have? We have, this is the metadata for each NFT. And yeah, we have the name of the NFT, we have the description, we define a media type. I mean, it could be different stuff. You could have images, could be nothing, could be an audio, it could be a 3D file, it could be a PDF, can be almost everything here. And another property is the media URL. So here we provide, for example, mostly will be used IPFS, I guess, but you don't have to stick to IPFS for sure. You can also use other alternatives. So there we have the URL, the prefix, and yeah, this has to be interpreted by the platforms respectively, for sure. And of course, the immutable attributes for your NFT. And I think about the immutable attributes, I already talked enough. Yeah, so this is our first proposal. Of course, we can extend, we can change. It's nothing set in stone yet. It's really a liquid process. So open discussion. So get in touch with us so that we can, yeah, go the best route that's needed for everybody. So now we come to our sample collection, which is deployed on testnet already. We called it apes stepping into the metaverse. Why is it called like that? We use DALL-E 2 of OpenAI, so an artificial intelligence to generate the images based on this text. So this is the output, or 3 of the images in this collection. We created in total 8 images with that statement. It's quite funny to see how DALL-E generates those images. But anyway, yeah. So the example code can be found on GitHub, and all the images are uploaded and pinned on IPFS using Pinata. So they should be there and not being lost. But anyway, the images are also included in the repository. So yeah, you're always able to restore them and pin them again on IPFS. Here I have provided a link to the contract, which you can follow to the Explorer and check it out. But yeah, this is our collection. And how did we do it, or how did we create it? First of all, on the left side, it's just a JSON file, a JSON representation of all the metadata of the whole collection. So as you can see on the left side, on the top is the name of the collection on contract level, which means we have apes stepping into the metaverse here. Then we have defined a symbol, AEX in that case, and then we have the array for all NFTs and provide a specific NFT specific metadata here. So yeah, like described 2 slides earlier, this is our proposal, and this is how we did it. On the right side, you find all the source code of this, the JSON file, the example, the scripts, how to deploy is all included in this repository I mentioned. So on the right side, what do? We initialize the contract instance using the SDK, and then we deploy the smart contract, providing the collection metadata, meaning in this case the name and the symbol. That we use the metadata type map is hard-coded in the mutable NFT contract. So you don't have to provide it explicitly from outside, it's hard-coded in the contract. We don't allow, this specific contract doesn't allow another metadata type to be used. Yeah, and after we deployed the contract, we output the data, we show the transaction hash, the contract address, the gas that was used for the transaction to be executed. And then we have just a simple for loop where we go over all the NFTs and call the mint entry point of the smart contract where we provide a metadata. Yeah, and this is executed 8 times. And after this is done, we have basically created our collection and minted all the NFTs we wanted to mint. It's easy as that. You can really follow that in the GitHub repository. It's not for the typical users yet, so you don't have a fancy UI. But yeah, I mean, this is why we have the hackathon, to let the community come up with great solutions, and I'm really looking forward to see something cool there. Yeah, and this is how the console output looked on the left side. You see the account we used, that it was successfully deployed, the contract address where it was, that was created, and then all the output for each NFT that has been minted, and the transaction hash, the gas used. So yeah, pretty cool and simple and easy to follow. Of course, if you do that, we did it all on testnet, if I haven't said that already. So this is not on mainnet, it's only on testnet at the moment. But it doesn't make sense. I mean, it's a random sample collection, which is not widely used. I mean, if somebody wants, he or she can deploy it on mainnet too. But yeah, hopefully we see many other meaningful collections and not too much spam. All right, what else can we do? I provided here a short example how I use the Æternity CLI. You can also check it out here on GitHub. And you can basically use the CLI to easily interact with your smart contract. So in the example repository, I provided the ACI file, which is kind of like the same like the ABI. So the interface to let programs know about how to, I mean, the whole interface, what functions are provided, what parameters are used, which types are being used. This is all described in the ACI and needed for the SDK to know how to deal with the inputs. Yeah, so in the first example, we make a static call. That's important here. Static means we perform a dry run on the node. So this is not a transaction that is actually being executed. It's just calling the node so that the node performs a dry run. So that doesn't cost anything. It consumes CPU, but it doesn't cost you anything. It's not a transaction that is mined on the network. Yeah, what do? We call the CLI contract call. We provide a wallet. Here I opened an issue in the CLI because for core static calls, I don't think we need a wallet, but currently it's needed. You provide a contract address, you provide the contract ACI, you say that it's a static call to not include the transaction into the network and mine the transaction. And then you provide the function name or entry point name, in this case, meta-info. And what we get as result, we get the encoded call data and of course also the decoded return value. On the right side, it's a bit better formatted. So we see it's apes stepping into the metaverse. It's with the symbol and a metadata type map, which was hard-coded in the contract. And then we call the balance entry point in the second example, where you have to provide an address. And in this case, I use the address of the minter, and the minter, or me, my person in this case, owns all the 8 NFTs so far. They weren't transferred to another address, so I'm still owning all the 8 NFTs. And the last example, I wanted to show you how to fetch a metadata for a specific NFT. Unfortunately, the decoded return value isn't showing everything, but we have tests included in the local network, which I provided a link for. This is something I will discuss with our SDK developers, and we will figure out as soon as possible. Yeah. But yeah, that's actually how you do it. So now what to build? What do we need, or what can you show us? I would like to see in terms of NFTs, right? We have many different possibilities. You're not limited. You can make DeFi applications or whatever you like. You get a comprehensive overview about that if you watch the welcome and introduction session again. But yeah, for NFTs, we need minting solutions, we need a launch pad, we need the marketplace, we need an auction platform, and then you can come up with additional ideas. But the upper three use cases are, there is the highest demand for, let's say it like this. On other chains, I mean, one thing to mention here is again that EVM-based chains, it's pretty easy to copy all the services, right? So if there is a new chain that supports the EVM, there's basically all the services created for Ethereum can more or less be reused quite easy. In our case, it's like we have developed a complete tool chain on our own because we don't rely on the EVM. We have our own virtual machine, which is much more efficient. We have our own smart contract language, which is functional, by the way. But yeah, so this is one of the reasons it doesn't exist out of the box, right? So we have to develop everything from scratch. And in my opinion, that's a good chance for everybody to get started here and to provide something meaningful for the Æternity blockchain. Yeah, if we have the first three areas, I'd like to see also some fractional ownership use cases or social campaign airdrops, which are verified by oracles. So we have also native oracles on Æternity. There are many possibilities you can check out, but yeah, I'm looking forward to see what you will develop. And if you're not already in our social channels, please join the forum, join our Discord, follow us on Twitter, join our Telegram channels, the official one and the Universe Two related one. Check out our website. And if you haven't signed up already for the hackathon, please visit the DevCourse page here in the bottom and join us. Find your team, get in touch with us, let us know if you find any problems. We're happy to help. Thanks everybody for listening, and if you have any questions, let me know now or later on Discord. Thank you.